Welcome back to my channel Conquer the Fear. In this video we are going to discuss about one of the most frequently asked tricky Java collection interview questions. So if you are attending any interviews or if you are preparing yourself for any tricky Java collection based interview questions, then this is the right video. Please watch this video because I'm going to explain each and every questions in details so that you can prepare and answer them very well. As these are one of the most important and the frequently asked, if you prepare this videos questions, then you are sorted and you can get the interview cracked up. So watch this video till the end. Let us take a look at the very first question. Explain the collection hierarchy. Now this is quite important because this give a clear idea of whether you have worked in the collection framework and you are aware of the list of interfaces and the implementation. Now the collection framework starts with the hierarchy, that is the collection interface, which is the root interface. Now most of this collection inherits this particular interface. Let's say list, set, etc., but there is a map interface which is not going to extend this particular interface. Okay, so now if you see at this particular collection hierarchy, there are list, set, queue, map, etc. So you will see all this particular list of interfaces and the implementation, okay, which is in the hierarchy. Now if you go to the basics of extension of the collection interface and the implementation, there are three basic interfaces that are going to extend the collection interface. Okay, now the very first one is list. Now if you look at this list, it contains the ordered elements, it allows duplicate elements, and it is going to support the index based searches and the random access. So the elements can be easily inserted with irrespective of the position. Okay, so that's how the list works in. Then comes this set. Now if you look at this set, it does not maintain any order for the element which is going to be indexed. So index based searches are not supported in this set. Also it does not contain any duplicate elements. So if a collection or a requirement is about whether you want to store some unique elements, this is the set. Now there is another collection, that is queue, which is going to extend from the collection, that follows a principle of first in first out. Then these elements are added at the rear end and removed from the front. Okay, that's how the approach gets followed up. Then there is a map which is not going to be extending from the collection interfaces, but the main idea is that it is going to represent, or it is going to store the value in a key value pair. Now this is the only interface which is storing the element in the key value pair, okay, in the collection hierarchy, I would say. Now it contains all unique elements, but you can have duplicate values in it. Okay, so that's how it works like that. Now we'll look at the hierarchy of the list interface basically. So as we spoke about the hierarchy of list, set, and in the first we'll discuss about the list one. Okay, so if you look at this, there is an array list is an implementation of the list. Now array list is nothing but a dynamic resizing array list. So it is going to automatically resize to the 50% of its original size when it is full. Okay, so that it is not synchronized and it is not thread safe as well. Okay, so that's how array list works like. Okay, now then comes the linked list. Now this is going to implement both the list and the dequeue interfaces. It is going to maintain the insertion order and it is not synchronized, so it does not support random access. The elements can only be iterated via list iterators. Okay, then comes the vector. Now if you see, vector is thread safe, it is synchronized, so it is going to maintain the insertion order. Now if you want to increase its size by it increases its size by doubling its array when it is going to be filled up. Okay, So the legacy class, it's very old class, but it is an important concept because of its thread safety. Okay, then comes the stack. Now this is going to extend from the vector, and it also going to follow the last in first out approach. Now the elements are always added and removed from the rear part only. Okay, the rear end actually. Then comes the set interface. Now let's look at the hierarchy of set interface, where it is what all in implementation we have. We have hash set, the very first thing, which is going to implicitly implement the hash table over there. Now then it contains only unique elements. It is going to allow only one null value inside it, and those are all unordered. It does not maintain any insertion order when you're trying to insert. Okay, so there is no order maintenance happening over here. Then comes the linked list. Now this is an, I would say, an ordered version of an hash set. Okay, so it is going to maintain its data in the double linked list across its element. Okay, this is going to preserve your insertion order, as I mentioned. Then comes the sorted set. Now this is going to be an sorted set which is going to extend the set. Then we have a it is going to, all the element must implement this particular comparable interface to have the sorting mechanism inserted. Then comes the, it is going to store the element in the ascending order. Okay, so tree set is an implementation class which is going to use the red black tree, which is going to store to ensure the elements are sorted and retrieved in a very fast way. So the objects are stored in ascending, sorted, and the ascending order over here. Okay, that's how it works in like that. Now let's look at the queue hierarchy. The first implementation is the priority queue, a queue where each element has the associated policy or priority over there. The highest priority is served first, irrespective of how it was inserted or in which order it was inserted. Then comes the DQ or an array DQ. So if you see, the DQ is a double-ended queue, which is going to extend the queue. Now each of this particular element added or removed from the either of this particular end, that is the rear front or the front end, right? Now array queue is an resizable array implementation of an DQ basically. So it has got no capacity restriction. It can grow like anything. Okay, that's how it works like that. Then comes to the map implementation. We have HashMap. So it is a non-synchronized. It is not thread safe. Okay, so it is going to allow one null key, but it can contain multiple null values over there. So the key must be unique for it. The value can have a duplicate over there. Then comes the hash table. Now if you look at this particular synchronized hash table is an synchronized version, that is, it is going to support the thread safe. Now it does not allow any null or a key as well as the value over there. So it's very legacy class. That's where it started. Okay, then we have a sorted map, that is, or a tree map, which is going to be a sorted version of an interface map one, where it is going to, extend from the map. Now all the entries in the key value pair are maintained in the ascending order based on the keys which were there inserted. Now tree map is going to is an implementation class which is using the red black tree for sorting. Now it cannot store any null keys over there. That's how it functions like. Okay, now let's look at the second question, that is, how does the map, or why does the map does not extend the collection interface? Now this is one of the important question. This is one of the, I would say, the core questions which you definitely find in all the interviews, and you must be definitely prepared for this, because out of this particular hierarchy, say as a list, set, and other things, they are definitely following the hierarchy, or they are part of the collection framework. But if map is not part of that particular collection framework, then you should know why it is not part of that. Okay, so let's discuss what exactly happens inside it. So the map interface is not going to extend the collection interface because the fundamental structure and the operation it is going to support is different. Okay, so the structure itself is going to is like, the map is going to represent the key value pair over there. So the collection represented, while the collection is going to represent like how it is going to store in the individual elements. Okay, so that is the reason this particular map is not going to extend the collection interface, because the structure is literally different and the how way they operate is quite different. Okay, now if you look at the structure and the operation, map is going to have the key value pair, while the collection is going to have the individual objects. Now when it comes to operation, the collection interface typically uses a method to add the single element. However, the map require both key and the value to insert the insertion, and it uses the put method over there. The difference is fundamental structure, and adding the mechanism makes it incompatible with the collection interface to be as a design part of it. Okay, so despite, if you see, despite of this particular, the map is still integral part of the Java collection framework, because it is only collection which is going to store the element in the key value pair. Let's discuss what is the difference between the synchronized collection and the concurrent collection. Now both of this synchronized collection and the concurrent collection, they provide thread safety, but they provide in a different and impacting, I mean, they are going to achieve it in a different way, which is going to impact the performance and the scalability over here. Okay, now if you look at this particular synchronized collections, we have vector, we have hash table, we have collection synchronized list. So the it is going to achieve the thread safety by locking the entire collection. So the object of every operation that are you going to read or write. Okay, so this is often done using the intrinsic lock of the collection instance. Now when it comes to performance, it can be much slower, because it is going to perform under the high concurrency, because only one thread can access only any part of that particular collection at a time, single time. So all the threads have to wait until the leading to contention, there's a problem over there. So this is an analogous to a single broad lock over the entire data structure, I would say. Okay, then we'll look at the concurrent collection. Now the examples are concurrent hash map, we have copy on write array list, blocking queue. Now thread safety is achieved using the fine-grained locking mechanism or an optimistic locking strategy. So for example, we have a concurrent hash map. Now it uses a locking stripping where it divides the collection into a multiple segments, and it only logs the specific segments which is being accessed currently. So this is going to allow the multiple threads to read, also to write in a different segment at a very concurrent level. So the performance wise, it is much faster, it is much scalable, but it as is going to perform under the high concurrency, because multiple threads can operate or a different part of the collection at a simultaneous way. So they are designed from ground up for a concurrent operations, concurrent access, and they are preferred in the multi-threading environments basically. Let's take a look at the one other question, that is one of the important question, I would say. You can't afford to miss this particular question, be prepared up. Now explain the internal working of hash map. Okay, now hash map is nothing but a key value pair which is going to be stored up, and it is one of the, as we already discussed, as the this is an map implementation. Okay, and if you see, it works like an on a hashing principle basically. Okay, so where it is going to store the key and value pair. Now if you look at this particular image here, you will see, like, you have an apple, you have an banana which is going to be stored, and if you see, it is going to calculate the hash function, it is going to pick up in which bucket it is going to store it, and then it is going to store over there in the bucket. Now uh, let's look at the other slide. Now if you see, at the storage wise, if you look at this particular hash map, it is going to store the data in a map entry, okay, object, which is going to encapsulate both the key and the value. So these entry objects are stored in the array of linked list. Often you can refer this as in buckets or a bins actually. Then comes the how you put that particular operations happening in the hash map. Now when you call a put key with the key and the value, the hash code method of the key object is calculated, called and called up. Now hash code is then used by the hash map internally for hash functions to calculate the index, the bucket location basically, in which it is going to there is an underlining array where the entry object should be stored over there. Okay, now the entry object which is going to contain the key and the value is then placed in that particular calculated index. uh, Now then we will look into the get operation, that is the get object. Now when you call this particular get, right, the hash code method of that particular provided key is going to again be calculated, and it is going to find the index over there. Then hash map is goes into that particular bucket, and then again it is going to pull that particular information. Then comes the, how it handles the collisions level. Let's say if you have multiple keys that are getting having the same index. Now since multiple different keys can produce the same hash code, it is called a collision. Hash map uses a technique called linked list to store, it is stores in the each array bucket actually. So if a collision occurs, it is going to put the operation in the new entry object, that is simply is appended to the new node to the linked list at the bucket. Now from Java 8 onwards, the linked list at the particular bucket become too long, the let's say certain threshold, it is going to it is going to convert it into a linked list into a balanced tree. Okay, so there is a balanced binary search tree that is called a red black tree, which is going to improve your performance whether you are trying to search, insert or delete an element. So this is done to prevent some worst case scenarios, let's say the performance of over of n to while retrieving all the element from the same bucket of the hash code, right? So that's what the benefit of it. Now then comes the retrieval process, where we are trying to retrieve when we have the collision. So when you're trying to get an element and that the linked list or the calculated index, it is going to iterate of the linked list over there. Now each entry in the object is using the equals method, which was provided by the key to compare it with the key stored in it, okay, in the entry object. Now when equal method returns true, the corresponding value of that particular entry object is returned. So this is why both hash code and equal plays an important role and must be properly overridden for a custom objects as a key to be stored up in the hash map. Okay, now this is also one of the important questions, why the keys are preferred to be stored as an in the hash map, right? So why it is preferred to store as a key, so that's the reason for storing it. Now let's look at the another question, that is what is the difference between the fail fast and the fail safe iterators. This is quite important because there are a whole lot of subsequent questions can be asked on top of this particular question, because this is an interview looked out for the initial question and then it tries to dig into more into the fail fast and the fail safe iterators. So make sure you prepare this very well, because on top of this there must be n number of questions can be asked on this. Okay, so consider this as a very very important question. Now this is if you see the fail fast and the fail safe iterators, they are different in performance and this the way it operate. Now if you compare the fail fast iterators, they are going to throw the concurrent modification exception immediately if you try to modify the structure internally. So let's say you are trying to add something, you are trying to remove something, let's say by another thread, while you are trying to iterate using one of the thread. Now this works directly on the original collections. Okay, so example, you are iterating over the array list or an hash map over there. Okay, so that's how it's try to concurrently modification exception is thrown over there. Now we have failsafe iterator. Now this does not throw any exception, because it is going to work on the underlining collection. It is going to modify the structure by the another thread, so there is no exception is been thrown there, because it is going to work on the clone actually. Okay, the collection of that particular time it is going to iterate is going to create a separate copy of that, rather than it is going to operate on the original how it was done for the failed fast iterators. Now this is going to change, the changes which are made in the original collections after the iterator has been created are not going to reflect in your iterator basically. Now the examples of iterator, the example of fail safe are copy on write, array list, concurrent hash map, which are part of the concurrency API. Okay. Now there is an assignment for you. So far we have discussed the most tricky and the important interview questions. Here I am listing you for your preparation purpose. There can be these questions also be asked up. Okay, I am going to show you all this particular interview question. Now if you look at this, the very first is explain the internal working of concurrent hash map. Now the similar to how hash map internal working was asked up, similar to this you will be asked about the concurrent hash map, because the best solution for a hash map alternative is concurrent hash map, and that's also very quite important when it comes to interview question. Now then comes the internal working of hash set. This is also quite important. Then comes why do you what do you understand by the blocking queue? We already discussed, right? But what is the difference between the comparable and the comparator interface when you would use one of them? Now this is quite important because you cannot miss this particular question to be unprepared. Can you explain or can you use any of these particular classes as a key in the hash map? What are the best practices for a custom key in the hash map? Now we already discussed, right? This is one of the important questions, because this is one of the confusing questions also, and some most of the people don't answer this. Why is concurrent hash map generally preferred over the collection synchronized map for the thread safe operation in a multi-thread environment? Now in order to answer this, you should be well aware of what is the concurrent hash map, how internally it works, right? So that's how the basics should be very clear on it. Explain the concept of identity hash map, when will be useful, and contrasting to how it is used with respect to the alternative of an hash map, right? How you can make the collection read only or an immutable? Why do you want to do like this, right? That can be the question asked up. Now please let me know if you want me to make another video for by listing all these particular questions and answer which I listed as an preparation for you. I can make that video if I get 2000 likes. So please share this video with the people. Also don't forget to like, subscribe and hit the bell icon. Thank you for watching. Also comment down in the comment section on which topic you want me to make the videos.